So good evening to all. Is the audio and video clear? Please say. Thank you. So any queries for the previous session on solvable for x, y, p and Clairaut's equation? So the last question which is given as a daily test for you, right? For asking for that. Okay, no problem. Tell me, where is the problem with you with that question? Yes, x minus yp is equal to p square you are asking, right? Is that accepted? Okay, x is equal to yp minus p square, fine. So your doubt is how to solve this, right? What is the method to solve this, right? Let us go with this question right now. So if you differentiate with respect to y on both sides, then it will be dx by dy is nothing but 1 by p is equal to p plus y into dp by dy minus 2p into dp by dy. So here our criteria is you have to make it into factorization, or if that is not possible, if you are able to represent that as linear model and you are going to solve that in the linear model. Okay, fine. Now tell me, is it possible to draw the factors there? Is it possible to draw the factors there? Okay. If it is not possible, then we have to convert it into linear model. So let us try for that. We take this value here, 1 minus p square by p is equal to y minus 2p. Then you have to simplify it further. So if you take dy by dp, is this acceptable? Say, right? Then it implies that dy by dp minus p by p square minus 1 into y now we are going to apply the integrating factor. So this value equals to minus 1 by 2 integral 2p by p square minus 1 dp e power. So e power minus 1 by 2 log of p square minus 1. So e log gets cancelled. This is the integrating factor. Accepted? All of you? Please check and tell. Right. Now we are going to calculate the general solution. Here the dependent variable is y. So y into 1 by root p square minus 1 is equal to integral q means minus 2p by 1 minus p square, nothing but 2p by p square minus 1 into plus integration constant c. Now, how to evaluate this? You take that p square minus 1 equal to t. Then you have 2p dp is equal to dt. So there is nothing but integral dt by t power 3 by 2 plus c. Accepted? Yes or no? Any questions? Now you can do the integration here. Then you substitute t value, nothing but p square minus 1. Now what happened? You have represented y in terms of p. Yes or no? So that if you substitute the value of y in the given equation, then the total thing will be converted in terms of p. So x and y together will give the general solution where x and y individually represented in terms of p. That is the conclusion. Fine. Any more doubts for this? Okay. Any other queries, please, regarding the previous session? Right. So, shall I start our today's session on higher order differential equations? Thank you. So can I ask one thing, that are you able to solve the exercise problems in the textbook what you are following after having this class session? Are you able to do that? Or still it is lagging behind you? Okay. So after doing that, can you attempt the previous year questions too? Okay. So whatever the questions are there, you please post it in Telegram so that everyone will have the access. Later I will take a doubt clarifying session on them, or I will provide the solution in the Telegram itself. Thank you. So let us start our session on higher order differential equations. Sure, go ahead with your previous preparation. Since the class videos are available to you, after the completion of prelims, go with the class videos again and go with the previous year questions practice. Then also we have the doubt clarifying sessions. You can attend them freely. Thank you. Right. So in this perspective, majority of the questions will be asked under this category. It has the variations. So standard procedures are there, or standard questions I will say. So in this, one category is Cauchy-Euler equation. One category is variation of parameters. And one category, non-constant coefficients. So these are the procedures available under this category of higher order differential equations. So far we have discussed first order differential equations. It is nothing but an equation involving dy by dx only. It has order 1. Now we are going to discuss the solutions of d square y by dx square, d cube y by dx cube, and so on. So an equation involving the differential second and higher orders. The total concept is mainly bifurcated into two parts, that is homogeneous type and non-homogeneous. However, questions are framed only on the non-homogeneous, and these are the categories coming under this part. So a differential equation of higher order is nothing but an equation involving the differentials d square y by dx square, d cube y by dx cube, etc., and having the coefficients in it, either constants or functions. In a typical manner, we simply write that f of x, y, dy by dx is equal to 0, or f of x, y, dy by dx is equal to some q. So whenever an equation is involving the terms coming under this x, y, and the differentials, right side part equal to 0, it is called a homogeneous equation. And an equation involving x, y, differentials, and right side you have some functions of x is called a non-homogeneous one. I think the definition is known to you all earlier. Am I correct? Yes or no? The definition of a higher order differential equation. Please say. Is it known to all or not? Fine. So since the definitions are not going to ask in the exam, straight away I go with the procedures first. However, I will write the definition part. So just hold on a second, I will write the definition. So usually a higher order differential equation form is defined like this. So where an minus 1, so on, a naught, all the coefficients are either numbers or functions of x. If the right side part is 0, means if q is 0, it is called a homogeneous higher order differential equation. If right side part is presented, then it is called a non-homogeneous higher order differential equation. And we are discussing only linear differential equations. And the two variations in this are, if the coefficients are numbers, we call it as constant coefficients. If the coefficients are functions, we call it as variable coefficients. So for variable coefficients, we have the methods prescribed as for constant coefficients, The methods are so please take a note of them. For constant coefficients, nothing but the coefficients are purely numbers. We use the methods, variation of parameters, and standard procedures. For variable coefficients, we have the techniques, Cauchy-Euler equation, variation of parameters, reduction method, etc. And usually, majority of the questions with 15 marks weightage will come under this category. 10 marks weightage will come under this category. Okay? Compared to previous topics, what we have discussed, this thing is very easy and comfortable once you know the procedure. So from here onwards, apart from writing dy by dx, we simply use the symbol d for d by dx. It varies from textbook to textbook. So usually d stands for the differential symbol d by dx. We call it as a differential operator. So for integration, we use 1 by d, nothing but the integrand operator, the integration operator. So if I have written an equation like d square y by dx square plus 5 into dy by dx minus 2y equal to 0. Since the right hand side part is 0, it is a homogeneous differential equation. Since all the coefficients are numbers, it comes under the category of constant coefficients, and using this symbol d, we are going to write it as d square y plus 5 dy minus 2y equal to 0 in a short form, d square plus 5d minus 2 of y equal to 0. So whatever the differential equation is there, by using this operator notation, we are going to represent in this way. This is called as operator form. In a simple way, we call it as f of d into y equal to 0 form. Okay? Are you getting the idea? Fine. First of all, I go with homogeneous differential equations part. That means where the right hand side is 0. Now, consider the homogeneous differential equation f of d into y equal to 0. For convenience, let us take the simple one that how to write its solution is, for this function f of d, we write it as an polynomial equation, nothing but algebraic equation, and we will find its roots. So you can take it as x or you can take it as a m variable. So for the coefficient part, we can write the equation as m square minus 5m plus 6 equal to 0. The algebraic equation, what we are writing, we call it as auxiliary equation. And some others write it as algebraic equation, whatever the terminology is there. Now we are going to find its roots. The roots are m equal to 2 comma 3. Accepted? Now, after finding the roots, the corresponding solutions of the equation are e power 2x is one solution and e power 3x is one solution. By known result, whenever the given equation has a solution, the corresponding combination of them is also a solution. So we write it as c1 e power 2x plus c2 e power 3x. So it is called as general solution of the given differential equation. We indicate with the symbol y suffix c. It is also called as complementary function. So for the general solution under the homogeneous category, we call it as complementary function. Also we can call it as the general solution. So what is the procedure in solving the homogeneous equation? You have to represent that in the operator form, write the corresponding algebraic equation for the coefficient, determine the roots. The values of the roots are taken as solutions, where C1 and C2 are arbitrary constants. They will be determined if the additional condition is given in the problem. So to determine C1 and C2, if any input is given in the problem, we are going to find it. Otherwise, this is the final answer. Okay? Is the procedure clear? Now what happens? Our discussion for homogeneous, you can take second order, third order, up to fourth order questions will be given to us for finding the solutions. So while finding the roots, the possible cases are, first thing, all the roots are distinct roots and real numbers. Second, you have the roots in which some of them are repeated, some are distinct. Third case, you will have complex numbers as roots. And sometimes these roots will get repeated also. So under the homogeneous category, while finding the roots, we will come across with the 4 categories. Okay? So I am not explaining the theory, how the root exists, etc., etc. I am simply sticking on to the procedure. Whenever a differential equation is given, how to solve it. That's all. Okay? Is it clear? Yes or no? Fine. So the example what I have taken here is the homogeneous equation in which roots are real numbers and distinct. So this is the general solution. C1 e power 2x plus C2 e power 3x. So apart from taking the problems, straight away I will give the ideology. Later on we will have some problems randomly and you are going to give the solution to me, which gives a better understanding between us. Let me say, suppose I have taken a third order equation, so I will get 3 roots. Now what happens? After writing the equation, the roots appeared are -1, -2, 3. So what will be the general solution? C1, C2, C3. These roots will be written in any order. So C1 e power 3x plus C2 e power -2x plus C1 e power -x. This is the general solution. Fine. Here all the roots are repeated. Suppose all the roots are distinct. Suppose the roots are repeated. Let me say m values has come like this. 2, 2, 1. So if you write the values as C1 e power 2x, C2 e power 2x, C3 e power x, since the value 2 is repeated, at this position we place x. So how to write the repeated roots? The procedure is, if a is a root, it comes as a 3 times. How to write that? C1 e power ax, C2 e power ax, C3 e power ax. So 1 time x, 2 times x square. So C1 plus C2x plus C3x square into e power ax is the formula. Okay. So for the repeated roots, this is the solution. For the remaining, we will write them as it is. Clear? Yes or no? Right. Let me take the other one. Suppose if the roots are happened like this. So I have taken a fourth order equation. So m has 4 values in which this is a repeated root, these are distinct. Since 4 roots are there, I must have 4 constants. So C1, C2, C3, C4. You can write them in any order. So C3 e power 2x, C4 e power 3x, C1 e power minus x, C2 e power minus x. Since this is repeated, you take x. This x will be written at a place. Here or here you can write that. No problem at all. So C1 plus C2x into e power minus x plus C3 e power 2x plus C4 e power 3x is the general solution. Now you have the clarity that how to write the distinct roots and how to write the repeated roots. Accepted? Is this part clear to everyone? Right. Now I go to the next part, that is complex roots. Suppose m value has occurred like this, 1 plus or minus 2i, let me say. Since complex roots will occur in pairs, 1 plus 2i is one root, 1 minus 2i is the other root. Now, for the complex number, we have the real part as well as imaginary part. So, the solution is taken as, for the real part, we take e, so e power 1x into, for the complex part, we take cos and sine. So cos 2x, sin 2x. So for plus 2i, we take cos 2x. For minus 2i, we take sin 2x. Since constants are required, so constants are taken here. This is the way to write the general solution. So for a better understanding, let us take the other. You take m is equal to 2 plus or minus root 3i by 5. So here real part is 2 by 5, imaginary part is root 3 by 5. So general solution is given by e power 2 by 5 into x, c1 cos root 3 by 5x plus c2 sin root 3 by 5x. So this is the general solution. Okay. So for distinct roots, we have seen how to write. For repeated roots we have seen, and this is the procedure for writing complex roots. So if you have a simple example, let me say m is equal to 1, 2 plus or minus I. Let me take. So what is the order of the differential equation? Four, because I got 4 roots. 1 is a root, 2 is a root, plus I minus I are the remaining 2 roots. So how to write the general solution? C1 e power x, C2 e power 2x. Here the real part is not there, so we have to treat it as 0. So e power 0x into C3 cos x plus C4 sin x. So this is the general solution. And e power 0x is nothing but 1, so you can leave there. C1 e power x plus C2 e power 2x plus C3 cos x plus C4 sin x. Okay? Are you getting the idea? So any more doubts in writing the solution for the homogeneous? So the solution of homogeneous is purely based on finding the roots and writing the solution. Because if you are clear with finding the roots and writing the solution, this will be used in finding the solution of non-homogeneous equations. So this thing must be clearly understood by everyone, how to find the solution of homogeneous. Okay? So shall I take the problems for you? I will give one after the other. You are going to represent me. Thank you. So I simply write the equation. You have to find a algebraic equation on your own. Yeah, complex I will repeat. So can you give me a complex number to me now? Okay, complex repeat you are asking, right? Let me say m is equal to plus or minus 2i comma plus or minus 2i. So what are the repeated roots? 2i, 2i, minus 2i, minus 2i. Accepted? Right. Since it has 4 roots, I have to take 4 constants. C1, C2, C3, C4. I have mentioned that plus 2i is taken for cos, minus 2i is taken for sin. So C1 cos 2x, C2 cos 2x. Since it is repeated, you take x here. So C2x, so C3 sin 2x plus C4x into sin 2x. In a simple manner, C1 plus C2x into cos 2x, C3 plus C4x into sin 2x. So this is the case when complex roots are repeated. So if you give some numbers for me, straight away I will write that. So you give me the roots, I am going to write the solution. That gives a good understanding. Give me the value of m. So 5 plus or minus 4i, right? So here real part is 5, imaginary part is 4, repeated. So e power 5x is clear. What will come as that's it. Okay? Is it fine? In the previous thing, you have real part is absent. Here you have real part is presented. That is the only difference. Except everything is common. So 5 plus or minus 4i comma 5 plus or minus 4i. I have taken. please understand, on the whole, you are just getting 4 distinct constants. So C1, C2, C3, C4. The number which is repeated, that will be represented with this thing. But real part is fixed here, so e power 5x will come here. If you want to elaborate this, for this we have e power 5x into C1 cos 4x plus C2 sin 4x. This is all the same root, so e power 5x into C1 cos 4x plus C2 sin 4x. Since it is repeated, you are putting x here, isn't it? That's why this part will come in a single expression like this. Accepted. So any other queries, please? If it is clear, then I will give the problems one after the other to you. Shall I? Thank you. So take the problem that d cube plus 6d square plus 11d plus 6 of y equal to 0. So please take 1 minute time and you are going to solve it for me. So you have to write the values of m to me, give me the numbers. I will write the solution. Let us cross check that. Yeah. So -1, -2, -3 are the roots. Nothing but you are going to get it as m plus 1 into m plus 2 into m plus 3 equal to 0. So m is equal to -1, -2, -3. So the corresponding solution is given by yc is equal to c1 e power minus x plus c2 e power minus 2x plus c3 e power minus 3x. So if everyone is clear, then I will take the other. So I have to know that everyone has solved it. I will wait, you go on your own. Because finding the homogeneous solution is most important for the other sessions. Since you have done it a long ago, it will be just a practice session for you. Because a separate exercise is not needed. So after the completion of Saturday's class, I will give a daily test for you regarding this non-homogeneous and homogeneous part, so that I will cover all the models possible there. So ODE contains two parts. One is this higher order differential equations. Later we have Laplace transforms. At the most, you can expect 10 sessions on the whole from now onwards, which includes at the most 20 to 25 hours, as I have given earlier. Because I feel that for Laplace transforms, we have done them already. The only thing is giving the formula and having a practice and how to solve the differential equations using Laplace transforms is enough for you with regard to previous year questions pattern. Am I correct in saying that? So, is everyone is clear with the root finding and this? If anyone has doubt, I will go for that. If you have any doubt with regard to finding the roots. So can I take the other one? Thank you. So please solve this problem. So let us wait for the others too, what they will give the result. So please check everyone. To confirm that, then I will write the general solution. Any other queries for anybody in finding the roots for this problem? Okay. Since the differential d is given by d by dt, we have to write the solution as, here the dependent variable is x, so xc is equal to c1 e power 0t plus c2 e power minus t plus c3 e power 3t. This is the solution. So usually for every problem, y is the dependent variable, x is independent. So we write e power x, e power minus 2x, etc. Here the dependent is x, independent is t. It is clearly mentioned in the problem. So we have to write the solution in this way. So can I take the other? Are you clear with this? So please note down this. So here d is nothing but d by dx as usual. So please find the roots of it. Yeah. I will give the logic. So may I know anybody has done it? So one thing is, if you observe the coefficients, it is 1, 4, 6, 4, 1. They are nothing but the coefficients of binomial expansion. If you know the Pascal triangle, plus minus symbols are varying. So since 4 is presented there, it is nothing but m minus 1 whole power 4 equal to 0. If you know the thing correctly. So nothing but m is equal to 1, 1, 1, 1. So the final solution is c1 plus c2x plus c3x plus x square plus c4x cube of e power x. That is the solution. 1, 1, 1, 1. So you can have the other method too. If you don't know that it will come under the category of m minus 1 whole power 4, we know that division method, we call it as synthetic division method. It's just nothing but at least we should know one root of the given equation. So what we have to do in the algebraic equation, m power 4 minus 4m cube plus 6m square minus 4m plus 1 equal to 0. In this, you have to substitute the numbers randomly, one after the other. Substitute +1, -1, +2, -2, +3, -3, etc. so that at least you should find one root of it. Then what happens? We will apply the division method. So write the coefficients 1, -4, 6, -4, 1. Since 1 is root, we have known this. We apply the division method like this. 0, we have to add this 1. 1 ones are 1. Please add -3. -3, so this is 3. 3. -1, -1, if we add them, this is 0. So, this is constant, x coefficient, x square coefficient, x cube coefficient. So, it will come as m-1 into m cube minus 3m square plus 3m minus 1 equal to 0. So, at this position also, if you know the other roots, you can go further. You can check with this 1, 2, 3, 4, what number will come as root here. So, but if you take 1 is the root, then 0. So, what happens in the next step, you are going to write that m-1 into m-1 into here, m square minus 2m plus 1 equal to 0. So, it is easy to bifurcate here. So, whenever higher degree equation is there, if you know the one root, we apply the division method so that you are going to find the remaining roots. Okay? Please check and ask. Okay, I will give the description. Once the big equation is given there, in place of the variable, you take the numbers randomly 1, 2, 3, 4, -1, -2, -3, etc. so that you should get at least one root. Okay? Fine. So here I know that 1 is the root. I have substituted 1 in place of m so that I got 0. Now I have written the coefficients in the order. See, constant, x coefficient, x square coefficient, x cube coefficient, x power 4 coefficient. However, if it is there like this, m cube -1 equal to 0, in such cases, cube coefficient is 1, square is not there, 0, x is not there, 0, -1. We have to write in the order. Highest power to the constant, we have to write like this. So here, everything is written in order. You take the root value here. Obviously, for the first position, we should take 0. You have to add these two things, 1 plus 0, 1. Again, multiply these two. 1 into 1, 1, add these. -3 into 1, -3, add these like that. If the number which is taken by you is root, then obviously the last value must be 0 here. You didn't get 0 here means the number taken by you is not the root. So here 1 degree is decreased. It is m power 4. Now it come under the category m cube. So m cube, m square, m constant. Again here you are going to check. So since I got one root, m-1 into, for the remaining expression I have written the equation. If you note the roots here, it is okay. Otherwise again check the previous method, trial and error. 1, 2, 3, 4, -1, -2, -3, etc. for this equation. Let me say if 2 is the root here, then the same approach will be applied here. Then it will come under second degree, then it is easy to find the solution here, the roots. You are going to decrease the level one after the other. 4th to 3rd, 3rd to 2nd, like that. Fine. So, till you need more under the explanation part? Thank you. So, let us take the other problem then. So solve the equation d cube y by dx cube plus y equal to 0. So please go ahead with this problem. The only difficulty part is getting the idea of how to calculate the root there. That's all. Nothing else is there. If anybody has any difficulty in finding the roots, you please inform. I do it on board. Otherwise, you do simultaneously so that there is no practice session required for you for solving homogeneous equations. Yeah. Now see, it is nothing but d cube plus 1 into y equal to 0. If you read the algebraic equation, it is m cube plus 1 equal to 0, the auxiliary equation. So you can take it off the form m cube plus 1 cube equal to 0. This is of the form a cube plus b cube equal to 0. So what happens? The formula is m plus 1 into m square minus m plus 1 equal to 0. So for this, m equal to minus 1 is the root. If you apply minus b plus or minus formula here, you will have 1 plus or minus root 3 I by 2 is the value. Accepted? So the final solution is yc is equal to c1 e power minus x plus e power 1 by 2x into c2 cos root 3 by 2x plus c3 sin root 3 by 2x. That was the solution. So please take a note of that, inform. Then I just want to take one more problem which gives you a good idea on the whole, right? So please take that. So please find the roots of it. Then I proceed with non-homogeneous part further. If anyone is facing the problem, you can inform. In finding the roots. So however, I will post a sample practice exercise for you so that you can practice at home. Mostly I will provide the solutions for you too on this homogeneous part to get a good practice. That's all. Shall I continue? So plus or minus 2a plus or minus 2a are the roots. Accepted all? A little confusion in getting that. If anybody has any doubt, you can post. However, I will write the final solution as yc is equal to since 2i is repeated, that was the final solution. C1 cos 2x plus C2 sin 2x plus C3 x cos 2x plus C4 x sin 2x. If you common the values, C1 plus C3x into cos 2x plus C2 plus C4x into sin 2x. That is in the simplified form, the solution. Please understand that C1, C2, C3, C4 are just constants. You can write them in any order, because you are not finding any value for the constants here, because no condition is specified in the problem to determine the constants. So can I take the part for non-homogeneous equations, how to solve? If finding roots is clear for everyone? Right. So as I mentioned earlier, non-homogeneous equations are mainly classified into two types. Constant coefficients and non-constant coefficients. So far we have done the problems of the form f of d into y equal to 0. Since the right hand is 0, it is homogeneous, and in the coefficient of y, the coefficients of d are nothing but simply numbers. So we have discussed the constant coefficients part. So in non-homogeneous also, you will have a function on the right side. Usually we denote it with the symbol q. So we are going to deal with constant coefficients for non-homogeneous, because it contains some standard procedures and formulae to solve. Later we discuss about non-constant coefficients. Now, what is the solution approach? So take the non-homogeneous equation f of d into y equal to q. As usual, whatever the part is there on the right side, you forget about that. For the coefficient, you write the auxiliary equation, find yc. Just like c1 e power x plus c2 e power 2x. So simply find the roots of m, the equation, and write the complementary function yc. Now, for the non-homogeneous part, you are finding one more solution. We call it as particular integral or particular solution, denoted with the symbol y suffix p. The formula is 1 by f of d into q. So how to solve this? Depending upon the right hand side function, some procedures are defined here to determine yp. If q has the following functions, say e power x, sin x, cos x, x power n, and e power x into something, then procedures are defined, and some more x power n into sin x or x power n into cos x, like that. If log x, tan x, sin inverse, cos inverse x, secant x, cosecant x are there, For these functions, procedures are not defined to find yp. Okay? Are you getting the ideology? So on the right hand side, Q should contain the functions like e power x, sin x, cos x, x power n, e power x into something, x power n into sin x, x power n into cos x. For those kind of functions, procedures are defined to find particular solution yp. The right hand side contains log x, sin inverse, cos inverse, etc., tan x function, cot x function, secant or cosecant. Procedures are not defined. However, one standard formula is there that yp is equal to 1 by f of d into q. This will be evaluated using the formula sometimes that if you write the denominator f of d as linear factors, say the formula for this is this is the formula. So please take a note of that. After noting, please inform. I will take an example too. First note down this formula. One by d minus alpha into q equal to e power alpha x into integral q into e power minus alpha x dx. So this formula is useful sometimes to determine tan x, secant x functions are there for non-homogeneous function. We use this formula occasionally, not always, in finding the particular integral. Majority of the problems will be solved by using the standard procedures if the right hand side part contains those functions only. Right? So just note down this formula. While doing the problems, I will define the procedure, how to solve it. Okay? So let us take the problem first. While doing the problem, I will give the description to you. Shall I continue? Okay. So the first problem is please note down this. So for this part, you write the auxiliary equation, find the roots, and give me the complementary function yc. So once you find the roots, give me the input. I will write the complementary function. Let us cross check that. So m value will come as 3 plus or minus 2i. So yc is equal to e power 3x into c1 cos 2x plus c2 sin 2x. All of you clear with yc? Say. Fine. Now, to find yp, please understand what is the function given in the right hand side. So it contains exponential function, so it is possible to find yp. So how to find? Yp is equal to 1 by d square minus 6d plus 13 into 8 e power 3x. As I have written, yp is equal to 1 by f of d into q is the formula. Now, 8 is a constant, so you place this side. Now, what is the power there? 3. So you have to substitute the power in place of d here. So what will be the denominator if you substitute 3 in place of d? 4. So the answer is 8 by 4 into e power 3x. Nothing but 2 e power 3x. So what is the procedure here? Whenever the right hand side function contains e power something, that power must be substituted in the place of d so that the denominator will become a constant. So that is our required answer. Fine. Are you getting the idea? So generally, the denominator is not equal to 0 always. Sometimes the denominator is 0. What we have to do? Let me say, take a function that suppose I have taken the equation like this. Straight away I have written the roots. Now the complementary function you can write. If you calculate the particular integral, so yp is equal to 1 by now if you substitute 2 in place of d, the denominator becomes undefined. Accepted? So what happens after writing the denominator as factors possible, whatever the factors they are, either linear factors or second degree factors, whatever they are, you remove the factors which will give the undefined solution. So if you substitute 2, it becomes undefined. It also becomes undefined. So you remove the 2 factors here. Consider the other factor. E power 2x will be taken as it is. Now tell me how many factors you have removed? 2 factors. So you have to write here x square by 2 factorial. If one factor is removed, if one factor is removed, x by 1 factorial, 3 factors are removed, x cube by 3 factorial, like that. So the number of factors will come as x power k by k factorial. Okay. So for this part, the same technique will be applied. 2 should be substituted at this position. So 1 by 5 e power 2x into x square by 2 factorial, nothing but x square by 10 into e power 2x is the solution. Okay. Yeah, Apart from doing like that, I have simply described the procedure. That technique will be used in the next model. Is it convenient to remember or not? Say. Fine. So the thing is, whenever right hand side function is exponential, say e power x, e power 2x, etc., the number in the power must be substituted in place of d, so that denominator will give you a non-zero number, which is our required particular solution. Okay? Accepted? Right. However, sometimes the power may become root of the equation. In such cases, if you substitute the power in place of d, you will get undefined value in the denominator. So what happens? After factorizing the denominator, you remove those factors which give the undefined solution. So here, the power 2, if you substitute it in the two factors here, it gives undefined solution. So these two factors we won't consider. We consider the factor just d plus 3. Since you are neglecting two factors, we say that x square by 2 factorial. If you neglected k factors, x power k by k factorial. So for the remaining part, in place of d, you simply substitute the power 2. So 1 by 5 e power 2x, x square by 2 factorial, nothing but x square by 10 into e power 2x is the solution. That is the procedure we follow if the right hand side is e power x. Okay? Are you getting the idea? Any other queries for anybody? Right. Let me give you an idea too in this model. So take an example that d square minus 5d plus 6 into y is equal to cos hx. Now, as we know, the roots here is 2, 3, so that yc is equal to c1 e power 2x plus c2 e power 3x. Accepted? Fine. Now, if you consider the particular solution, since cos hx is there, can you write it as in terms of e? Just like e power x plus e power minus x by 2. Accepted? So, yp is equal to 1 by d square minus 5d plus 6. Cos hx will be written as e power x plus e power minus x by 2. So 1 by 2 is a constant. You are applying this thing individually here. Accept it all, the procedure. Now you are going to substitute the powers here. Since the power is 1, you substitute 1 here in place of d. Here the power is minus 1, you substitute minus 1 here in place of d, which gives the particular solution. So what is the number here? If you substitute 1 in place of, right, it is 2. For the second, 12, right? So 1 by 2 into Can I write like that? All of you. Now, the general solution is y is equal to yc plus yp. So you have to combine these two things as general solution. So it is c1 e power 2x plus c2 e power 3x plus 1 by 4 e power x plus 1 by 24 e power minus x. This is the final answer. What if e power complex numbers will say? That thing actually won't come. So you are going to substitute the same complex number there, nothing else. Right? So if it is e power I theta, simple complex number, we substitute I in place of d. So if it is e power 2i, we are going to substitute 2i in place of d. That's all. Whatever the number is there in the power, we are going to substitute there. Whether it is complex number, rational, irrational, we don't mind. Just substitute the number in the power in place of d, get the evaluation of it. Okay? Thank you. So in the previous problem also, which I have taken as an example to you, the general solution is given by yc plus yp. So what is the procedure for non-homogeneous equation? For every equation, we have to find yc, that is common. Writing the auxiliary equation, finding the roots, c1 e power x plus something, we have to write it, that is common. Secondly, depending upon the right hand side function, we are going to find the particular solution. And particular solution will occur for some kind of functions which I have mentioned already. And what is the general solution? It is nothing but joining the two things, yc plus yp. Okay. In this module, the other one is, let me say, we have taken that square minus 3d or minus 2d plus 1. So can you write the yc first? So it is nothing but m minus 1 whole square equal to 0. So m is equal to 1 comma 1. Yeah. So yc is nothing but c1 plus c2x into e power minus x. Accepted? All. Now, for finding particular solution, since only constant is presented there, so we treat the constant as e power 0x. Accepted? So it will be treated as 5 into 1. So 1 is nothing but e power 0x. The power contains 0. So you are going to substitute 0 in place of d in the denominator. So 1 by 1 into 5 into e power 0x. Nothing but 5. Okay? If you want another example, So by default here the constant comes. We have taken that d square minus 5d plus 6 into y is equal to 3 by 2. So what happens? Yc is nothing but c1 e power 2x plus c2 e power 3x. For yp, 1 by d square minus 5d plus 6 into 3 by 2 into e power 0x. So if you substitute 0 here, the constant will come by default. So it is 3 by 2 into 6. That is nothing but yp. Okay. So the general solution is given as common. Y is equal to yc plus yp. That is as usual in writing the final solution. So we have done the homogeneous part when the right hand side function contains only e power x. So here it contains 4 modules. One, the roots are distinct. Second, we have repeated roots. Third, when cos hx, sin hx are there, we are converting them in terms of e and solving it. And 4, when the number is a constant on the right hand side, so we treat it as that number into e power 0x and we are substituting 0 in place of d. Okay. So these are the 4 modules will come when q contains e power x as the function. Clear to all? So in the next session, I am going to take the particular solution for other functions. I will give the procedure and randomly I will solve some of the problems. So that is for our today's session. Now you can ask if you have any queries with this module. Anybody has any doubts? Laplace transformations will be covered later. Once ODE is completed, see ODE is totally up to higher order differential equations, then Laplace transforms will come. Because the fundamental question in Laplace transforms is, using Laplace transforms, we have to solve ODE, the ordinary differential equation, usually second order differential equation, with the initial conditions mentioned. So, without knowing the procedure and the equation of ODE, you cannot apply Laplace transforms there. So, this is half of the syllabus or 3/4 of the syllabus. The remaining 1/4 is nothing but Laplace transforms. It will be covered later after completion of this thing. Higher order differential equations.